Good afternoon, everyone, and welcome to another LinkedIn live session. Today about PTP traffic and infrastructure monitoring, a must, not an option. Briefly about the agenda for the next 30 minutes, we will start with a quick overview, a PTP walkthrough, and then conclude the session with a couple of live demos, how we monitor the PTP ecosystem with DataMiner today. Just I want to point out something, PTP monitoring, that's not something which is still in the making, that's reality already today. A lot of our customers have PTP ecosystems. They use DataMiner to monitor their PTP ecosystem. On the right-hand side of that slide, you see a couple of customers we have actively in use with PTP, and also our manufacturers, companies like Meinberg, Telestream, Arista, Cisco, you name it. Those are the ones providing PTP infrastructure, and those are the ones we have integrated already with. So first of all, what is PTP? PTP stands for Precision Time Protocol, and it's a mechanism to distribute time across a packet network. There is a standard for it. It's called the IEEE 1588 standard. There are multiple versions out there in the meanwhile. And the way PTP works in principle, it sends messages from a master to a slave clock to distribute time across the network. And you probably have heard about this already. There is an algorithm used. It's called the best master clock algorithm, BMCA, to adjust time inaccuracy and to select the best grandmaster or master clock in a network automatically. And where is PTP used? Obviously in a variety of different industries. That's the media industry, but also network service providers, telcos, mobile networks, you have data centers, power industry, finance, automotive, and a lot more. And to support all those industries with their slightly different requirements, the PTP standard supports different profiles. There are profiles that have been defined by IEEE, profiles by ETU, IEC, but also SMPTE for the media industry, for example. And when you look into how to monitor a PTP ecosystem, depending on the profile, the monitoring needs are slightly different. That will be important as well. And why PTP monitoring at all? Before we look into how we do it. PTP itself, it's a mission-critical service in every industry. And what happens with the mission-critical services, sometimes things can and they also do go wrong. And for us, there are a couple of different reasons why that happens. First of all, it could be because of some what we call bad foundation, which is sometimes a design issue or bad configuration. That could be the network design. People using non-PTP aware switches. Sometimes you see a mix of different versions of PTP. We have a version 1 and a version 2. Then people use networks which are not routed, and that could cause problems in a PTP system. But also the PTP configuration itself, there's a lot of parameters you have to set on every PTP device. Those are the PTP parameters, but also the settings for this BMCA algorithm you need to configure, the messaging rate intervals, how often do you send certain PTP messages across the network, a couple of more things like communication mode, etc. Then also network issues. PTP is either unicast or multicast traffic, and those packets can be either missing or corrupted, like any other network traffic. You can also have trouble with increased packet delay variation, which is basically jitter in the network. Or you have to deal with network asymmetry between the receive and transmit path, between sender and receiver, and that also causes this BMCA algorithm to slightly calculate inaccurate timings. Or you might have issues with multicast, which is also a typical issue. And then the PTP node itself. Nodes can go wrong. A grandmaster, the main clock, or the boundary clocks, there can be failures on those. You can have a loss of external reference. Your GPS, your GNSS source gets lost. You lose the satellite or the connection to the antenna. And also what we see are implementation bugs. That sometimes that BMCI algorithm or the PTP master election process has been implemented not 100% according to the standard. That can also cause some issues. And why is PTP monitoring a challenge? Because we do monitoring since many, many years with DataMiner, but why specifically PTP is a challenge for our customers? Let's have a look into the media industry as an example. There we see that move from SDI to IP. Technology is changing. In the past, when you look back into SDI, there was only something like black and burst or tri-level sync and SDI. This was a signal not really required to monitor because not many things ever could go wrong. And now we have the transition to IP that is still ongoing. PTP is still relatively new to the media and broadcast industry, only a couple of years. The standards are out there. That is a challenge in itself. And then when you look into the operational teams, there are different teams. From the past, the monitoring teams in broadcast, they were historically separate from the IT and NOC teams. And now a broadcast operator in an MCR operation, for example, he needs to be familiar with PTP, but there is still a lack of experience, a lack of knowledge, lack of expertise. That causes trouble. And then for us, a very important aspect is PTP ecosystems. They're always multi-vendor environments by nature. You have the grandmaster manufacturer, you have the boundary clock vendors, Cisco, Arista, Juniper, etc., the slave devices, the receivers from all kinds of different vendors. And all of those vendors, they usually implement PTP in a slightly different way. Let me give you an example on a multi-vendor environment from our experience. For sure, we have the standards, we have the recommendations, they're all available. But the vendors, they use those standards and they implement things in a slightly different way. As we said, there could be different APIs and interfaces. There is no standardized API for that. There are different sets of supported parameters. Not every vendor supports all of the defined PTP parameters in the standard. And what we see more often, they give parameters different names, values, units, intervals, etc., which makes it difficult to monitor and also inconsistent. And here is an example. For example, the PTP announcement rates. Defined as a log value, for example, I define it as -2. That's my value I want to read. And here are 5 different examples from 5 different vendors, how they implemented that exact value. First of all, you see they gave the same thing a different name: announce, announcement messages, announce interval, announcement interval, etc. Also, the values and units are slightly different. Some are showing up as a string, some are showing up as a decimal value, some are showing up as a log value. Most of them don't even have a unit. So for an operator, it's slightly confusing. Not easy to identify if a -2 equals the same as 4. And those 5 different values you see here, they all mean the same thing, but shown in a different way. So what do we need to monitor PTP? We need PTP monitoring tools for operations that streamline what we say immediate parameters and data. For example, when I go back 2 slides here, that the same thing will be shown in the very same way to avoid those confusions coming from the fact that different vendors implement things in a different way. For example, the announcement rate, I want to see in something human readable, not in a log value. I want to see something like I have X messages, 4 messages per second. This is my setting on a PTP grandmaster or boundary clock. Must be easy to use. Remember, we have that challenge that you don't have everybody being a PTP expert in the operations. And what's important on PTP, you first need to detect that there is a PTP issue at all, and then help troubleshooting and fixing the problem. Detecting that there is a PTP issue is not always obvious, and we will have a look into that. What to monitor on PTP? When we say PTP monitoring, we say everything that is required to successfully deliver PTP. Those are the PTP nodes, obviously the grandmaster, the boundary clocks, the transparent clocks, those are the switches, but also the slave and follower devices. And then what we call the PTP supporting infrastructure, like the GNSS source, my GPS antenna, the network infrastructure, PTP runs across a packet network, and also the PTP traffic, which is the network traffic as such, but then specifically the PTP traffic, the PTP packets. And altogether, only then you get a full overview of the health of your PTP ecosystem. Now let's have a look into a couple of PTP monitoring examples, how is data miner used to monitor PTP, a PTP ecosystem? We have prepared like 3 different demos, and why is that? We say PTP monitoring requires different front ends for different people for specific needs. You might have the PTP expert who needs to know everything about PTP to the very granular detail, every single parameter. He knows about everything that is going on in PTP. He has engineered PTP. He needs to know a lot more than other people who only want to see if a device I have just added connects successfully to PTP. On the right-hand side, we have what we call data miner dashboards. And then you see another screenshot here. This is a Microsoft Teams bot. That's probably for people who are only interested in a very high-level overview of PTP. Is my PTP connected to the antenna? An example here, we have the craftsman mounting a new GPS antenna on the rooftop. The only thing he's interested in, when I move the antenna, is my grandmaster still getting a proper GPS signal or not? Everything else, he doesn't really care. Now on the PTP app, let me try to bring up one of our demo systems here. That's a data miner system, what we call here an embedded application, our data miner PTP app, where you see a summary screen very briefly that gives you a rough overview of all PTP nodes and their health state from a PTP perspective. We have a couple of grandmasters here, boundary clocks, there is no transparent clock, and slave devices. Then you see who is the current grandmaster, not only the ID, but also a proper name to make your life a bit easier. And you see the role. It's the preferred grandmaster. That means that's the grandmaster that should be the grandmaster when everything is going well. When there is a failover to a second grandmaster, backup grandmaster, we call it the potential grandmaster. Still not bad, but not an ideal situation anymore. Another thing here, you see all the reporting nodes. We have like 40 PTP nodes, boundary clocks, slave devices, and they're all synced with the active preferred grandmaster, which is a good sign. Sometimes it happens when you add a new device, a new PTP device, they sync to itself because they probably don't see the grandmaster or any boundary clock. It seems everything seems to be okay. That new device reports, I found a grandmaster, but sometimes you don't realize that it found itself as a new grandmaster, and then you would see that immediately here. Also, when you click here on the alarm buttons, you see there are a couple of PTP nodes that have one or the other problem. For example, here there are PTP nodes that have set the wrong priority. That's a configuration issue. Data miner compares the desired configuration versus the actual configuration, and if there is no match, we will indicate that one here. Let's have a look at some other parts of that application. Here is an overview of all the nodes again and their health state, the grandmasters, the boundary clocks, the slave devices. Then you can go into more details. For example, compare the preferred grandmaster and the potential grandmaster, just a visual comparison. My preferred one has a priority 2 flag of 1. The potential one has set priority 2 to 2. That's how we distinguish, how we engineered the network to say, this is my main, my preferred grandmaster, that's my potential grandmaster. So things are okay. On the boundary clock side, you're also interested in who's my grandmaster, who's my parent clock. That's like the next master from the boundary clock perspective, and what are my local clock settings, because I'm another master clock as a boundary clock. And you can start comparing again here a couple of boundary clocks. Or for more IT savvy people, you might want to look into more a network overview like this, where you see here's my grandmaster, there is this little clock icon indicating this is my active grandmaster right now. If there would be a failover to another one, that clock icon goes to another node, another grandmaster. And you see there are a couple of devices which show an alarm. We have seen already this was a configuration problem. And certainly I can go then to all the details of each and every device. Like here, my grandmasters, look into more details. This one is okay, but my device here had a bad configuration. I see the PTP priority was set wrongly. I know I need a different value. It was set to 225. I want to make it to 255 because this is how I engineered my network. I fixed that. The issue disappears, the alarm disappears, and also that's being reflected then here, for example, which is now all in green. On the nodes, we have also the slave devices and then analyzers. In our demo system, I didn't add any analyzer, but let me show you on one slide what we do with analyzers, because that's a very important thing. Data miner as such is not a PTP analyzer. We do not analyze packets. A lot of the equipment we interface with, however, like boundary clocks, also slave devices, have some built-in analyzer capabilities. For example, counters for the number of messaging packets they receive. But then you have specific PTP analyzers from different vendors like Telestream, Fabrics, also Wireshark is an analyzer, Meinberg, EBU List Tool, Calnex, Leader, etc. And with those, we also interface and we can use them to complement the full picture on what's going on in the PTP ecosystem. So we take the results from an analyzer, and what we often do, we start comparing the actual PTP configuration versus the measured packets in the network. For example, you have set your PTP grandmaster clock to send one announcement message per second, but the tester measurement device, the analyzer, measures something different. You would get an alarm. Something is not quite right. Either some messages got lost on the way, or the grandmaster doesn't do what you said. A second important aspect here, we also automate analyzer workflows, and that can be the configuration of the analyzer itself. For example, when there is a critical alarm, to start a Wireshark capture and store a PCAP file, or to notify Tier 2 support to further investigate via email or a Microsoft Teams message. But also, we configure a lot when it comes to port mirroring and tab aggregation. And what is that? Imagine you have one of those analyzers, you have a big network, but in fact, when you have an analyzer, you only ever measure that part of the network where the analyzer is connected to. And to be able to measure something different, let's say you have a problem on a media edge device with PTP, you want to measure those packets. To measure those packets, you need to have a copy of those packets. That's done with switch port mirroring. And tab aggregation is another level where you do switch port mirroring on a switch level. And in fact, you connect your tester measurement device to that tab aggregation switch. And with that, you can measure each and every link and each and every packet in the network straight on that switch without reconnecting your analyzer in the network. And that's something that requires usually a lot of CLI commands to reconfigure the switch. And that's something we can do also with data miner and automate that part to use your analyzer in a more efficient way. Let's have a look at dashboards. So the PTP expert, as we said, he can do everything, look into all details. Dashboards are probably used by the IT guy. Remember, we need to do infrastructure monitoring. Let me bring up a few of those. Here is a dashboard. This is live data from our headquarters monitoring a couple of Cisco switches. You see, we monitor the usual things like CPU utilization. Don't underestimate that one. It has an impact on PTP. When the CPU utilization goes up, is too high, the switch gets into trouble. PTP messages probably got lost, and you will see an impact on PTP. Same happens on the utilization rate of the switches. Here, everything is fine. We have a couple of switches here. The maximum utilization rate on one of the interfaces is less than 70%. Everything is good. I can certainly look into more details here. Also the utilization rate over time, etc. This is our uplink, which is still okay, nothing really critical. So from an infrastructure perspective, because we need to monitor the infrastructure to make sure PTP is all right, everything is good. Another dashboard here. This is coming from one of our partners, Arista. We have a live connection to their lab in the US. You see there is a spine leaf network, and we do similar things. We monitor the usual KPIs, free memory, CPU utilization, but I also see that this switch has been configured as boundary clock, has a couple of master and slave ports, but you see the offset from master, the mean path delay, is 0, and the clock identity and the grandmaster clock identity is just the same. That means this switch has not been configured properly yet, It's listening to itself. It doesn't see the grandmaster. Why is that? That's a lab environment, and the setup is still in the making. But then again, you also need to make sure your interface rates don't reach a certain threshold. Shouldn't be reaching 100%. That's something we monitor, so we see the performance over time. And not to forget about digital optical monitoring, DOM, like optical RX, TX power, temperature, the voltage, which has a big impact when one of your SFPs on a fiber optic switch has a slight issue, like a degrading RX or TX power. You will see an immediate impact on your PTP quality. Same goes for switch interface errors that we track here. Here we have 0 errors, which is a pretty good sign. Then another dashboard we have done together with our partner Mindberg, that's coming from another lab. Let's say I'm in an MCR environment. I'm not the PTP expert, but I'm mainly interested if my grandmaster is the grandmaster I have engineered, which is the case here, my preferred grandmaster. Everything is green. I have my potential grandmaster. This one is up and running. Very important to monitor in case my main grandmaster goes down, that I know the second grandmaster can take over. Then I have 2 slave clocks here. We monitor the BMCA parameters, but also the GPS source, GNSS monitoring. For example, the number of satellites, the good satellites and the satellites in view. I have this one. I have my potential grandmaster. They're all good. They have a proper GPS source. Now what I can do, imagine you want to share some data with somebody else. My colleague Marin, she's waiting in the background, and let's assume she's sitting on an OB truck. I'm in the MCR. We have an OB truck who connects to one of our studios, and Marin needs to connect to our PTP ecosystem because the truck needs to connect to our own time domain. What we can do with data miner dashboards, we have a possibility to share a dashboard. Hi, Marin. I hope you can hear me. With just anybody outside of the company, and that's important. It's not that I share this dashboard internally now. What I can do, we have a cloud-connected data miner system. And I can type Marin's private email address. Marin, you have to let me know if there is an issue or a typo. And I just sent her a message. I click on share, and what will happen? Marin will receive an email in 10 or 20 seconds. And she will have access to the very same dashboard across a secure and encrypted connection, and can open that dashboard. And instead of calling me to be assured that she's now connected to the right grandmaster, she just logs in. And you see on her screen already, the first time she logs in, she needs to register, in this case with her LinkedIn account. She signs in. She has received the email, clicked on that one, and now the dashboard will open. And what you see, it's the very same information, the very same dashboard. And when we compare both dashboards next to each other, it shows the same information. And let me try on another screen to create some error now on the dashboard. Let me see if that works. You see, there is a little red dot. I changed a parameter on the main grandmaster. That will lead to a failover in about 20 to 30 seconds. And you see already that the screens are failing over here from one to another. You see the BMCA algorithm is kicking in, and Marin sees in real time that something is going on. She would not wonder anymore that, or panic that something went wrong. She has a good overview of what's going on. There will be a different grandmaster, which is my backup grandmaster, but that's still all right. Nothing is too critical. We will still be operational and on air. That's a key aspect, that we have the same information available for different teams internally, but also externally. And you've seen with just a couple of clicks, I share that information in real time. There is a slight delay for sure, but that's only within milliseconds. And if I wanted, I could even give control to Marin. Right now she has read-only access, but there is also a possibility to give her control, for example, to reconfigure PTP in one way or the other. Marin, thanks very much. See you later. Now, another one we had in mind. Let me fix first PTP again, bring it back to the regular state. You see my error is gone and the BMCA algorithm will kick in. And in a couple of seconds, everything will be okay again. One more demo I wanted to show is our Microsoft Teams integration. Maybe the craftsman who is only interested to see if the antenna is still syncing my grandmaster. What I did, I'm on my Microsoft Teams client here. I've downloaded our data miner chatbot. Everybody can go to the Microsoft Teams catalog, search for data miner, download a chatbot, and connect and interact with a data miner system. And there is one command one of my colleagues has built that's called show PTP info. That's all I need to know. That's all I enter, and I start communicating with data miner. And you see that command gives me a couple of options. I can ask data miner and say, show me the grandmaster. Fine, that's all I need to know. My current grandmaster is that grandmaster blue here. The clock source is GPS, that's my grandmaster ID. Everything is good. I can also get some other information, and those are just examples, like show me the alarms. Remember, one alarm was there. We fixed that by changing the priority to 225. We still have 4 alarms left. Gives me a very quick overview on the health state of my PTP ecosystem without going to any of the dashboards or in detail with the PTP application. And here is another example. Get node status overview. I run that one. And it shows me pretty much the same information that I have seen on the PTP app, but in a super easy way to say, those are all my nodes. Every node is synced with the active preferred grandmaster. So things seem to be all right. So once more, to wrap it up here a bit on the demos, let me go back to my slides. It's important to, first of all, get the information, to have the information available in data miner in real time, but then again, to provide the right information to different teams at the right time, inside and outside. That's an important aspect of your company as well. Outside of the company, remember that one with data miner dashboard sharing. We have an easy capability to share data with just anybody out there with just a few clicks. Or you can do the very same thing with that Microsoft Teams bot, where you can have interactive conversations with data miner in a pretty human and natural way. Just start talking to data miner and you will get the right information back. Conclusions, PTP monitoring. In short, it's a must. Otherwise, you will be in trouble sooner or later. And also important, it's more than just using a PTP traffic analyzer somewhere at one point in the network. What we do with data miner, we integrate those traffic analyzers, PTP analyzers, to complement the PTP infrastructure monitoring part with analyzer information to get the full picture. We also have seen that PTP things going wrong are often related to bad configuration. What we do there with data miner, we automate configuration with PTP. We didn't talk about this much, but that's an important one as well. And not to forget about security workflows. When you configure PTP ecosystems, always think of configuring your ecosystem in a way that it's more secure. To give one example here, on a boundary clock, you can say, I define certain interfaces as, they call it, master only. And if ever you connect accidentally a device that wants to become a grandmaster, which should never become a grandmaster, but you connect it to a master only port, nothing will go wrong. If you don't add that security feature, that bad device, badly configured device, could all of a sudden become the new grandmaster, and then you are in trouble because that's never supposed to be the grandmaster. And then not to forget about PTP monitoring is not a job one single person does. Usually have a single PTP expert in the company, but more people are involved when it comes to PTP monitoring to know and to be assured that PTP is doing okay. And that involves multiple teams, different teams with different needs, inside and outside of your company. And last slide here. If you want to try or buy, get in touch. There are a few links. My colleagues will share those links as well on the chat, where you can share your email address with us. We will do the very same thing that I just did with my colleague Maren. If you're interested to test those live dashboards, we are happy to share them with you. You can also have access to our PTP app. That's a simulated environment. That's part of one of our online data miner systems. And then certainly get in touch with our sales team. We have links in case you don't know your account manager or manager who's responsible for a certain region. Check this out. And to mention it, on the commercial side, that's an important one as well, something we didn't have before. For many, many years, we had perpetual licensing only, but now, since a couple of weeks or months, we also offer a usage-based licensing model. Have a look. There's another link out there where you can inform yourself, or just call and reach out to one of our sales persons. And if you have any other question, also feel free to ping me, give me a call, send me an email, or reach me on LinkedIn. And with that, I say thank you very much and see you next time for our next LinkedIn live session. Thank you.